Hi friends, welcome to my YouTube channel. In this video we see about the some rearrangement reaction. When we see this rearrangement reaction, first of all see the definition what's meant by the rearrangement reaction. The rearrangement reaction is the broad class of organic reaction where the carbon skeleton of a molecule is rearranged to give a structural isomers of the original molecules. Often a substituent moves from one atom to another atom in the same molecules. That is the rearrangement when that is takes place, that is the carbon atom is attached to the new substituent takes place. That is called as a rearrangement reaction. When we see the example, you must be clarify this. The rearrangement reaction are of two types, that is the intramolecular and intermolecular rearrangement reaction. Intramolecular rearrangement means that the rearrangement takes place between the same molecules. That is called as intramolecular rearrangement reaction. And the intermolecular rearrangement reactions, that is the when the rearrangement takes place between the two molecules, this is called as intermolecular rearrangement reaction. Then we see the name reaction which are called as the Sommelet Hauser rearrangement reaction. In actual what's are happened in the Sommelet Hauser rearrangement reaction, we are taking here. When you take the benzyl quaternary ammonium salt, this is the benzyl quaternary ammonium salt, which are reacted with the soda amide, which acting as a strong base, which removed the H plus ions from this structure. So we are using here the soda amide as a strong base, and it gives the orthomethyl derivative of benzyl tertiary amine. That is the methyl group is attached here. So it is rearrangement takes place between this molecules, and the formation of the product takes place here. So this is the known as the Sommelet Hauser rearrangement reaction. When we take the example, that is the mechanism of this reaction, how actually gives the product. So when we use the benzyl quaternary ammonium salt, which are reacted with the strong base, that is NaNH2, then these H plus ions is removed from these structures. These H plus ions is removed from the structure, and these electron are transferred towards the carbon atoms, and carbon get a negative charge. So there is the carbon get a negative charge, and formation of the lights takes place. We are see the definition of lights, that is the structure which contain the carbon atom as a negative charge and attached to the heteroatom which contain a positive charge. Here nitrogen is acting as a heteroatom which have a positive charge, and this nitrogen which attached to the carbon atom with a negative charge. So this acting as the lights, and here we are called as the lights A, because in this structure two lights are formed when this carbon that is the carbon atom attracted this electron towards itself, and carbon get a negative charge, and these H plus ions which are attack on this carbon, and formation of the CH2 takes place, and the formation of lights. Second lights takes place here. This is the lights B takes place here. Here carbon get a negative charge, nitrogen having a positive charge which acting as a heteroatom, and according to the definition it acting as a lights because carbon negative charge attached to the nitrogen having the positive charge. So these lights then these negative charge attack on this position of the benzene ring, then this bond is shifted towards this carbon atom, and here formation of the double bond takes place, and that's why this bond is attracted, these electrons are attracted towards the nitrogen, and the formation of the resultant structure is as like that. Here one hydrogen atom of the benzene ring is attached here, and carbon get a double bond is formation takes place here. Then the deprotonation of this takes place. This hydrogen atom is removed as H plus ions, and these electrons are shifted towards this, and then these double bonds electrons are shifted towards this carbon atom, and carbon get a negative charge, and the formation of the resultant structure is like that. Here carbon get a negative charge, and this formation of this structure is takes place. After the protonation, when the addition of H plus ions takes place here, then this H plus ions H plus ions is attached on this carbon atom, and the formation of here the CH3 group takes place. So there is the formation of the CH3 group takes place, and the formation of product, that is orthomethyl derivative of NN dimethyl benzyl amine takes place. So here is the definition of the lights we are taking here, that is the lights are the defined as the compound in which positively charged heteroatom, these are the heteroatom nitrogen, oxygen, phosphorus and sulfur, in which one of the attached with a positive charge and is connected to the carbon carrying the negative charge. So this is called as the lights. When we see that this in this structure, that is CH negative charge, and here the that is the phosphorus or nitrogen is takes place here, nitrogen having the positive charge, and this is the CH3 and another CH3 is attached here nitrogen acting as a heteroatom which contain which has acting as a positive charge, and carbon which has the negative charge. According to definition, so this acting as a lights. This is seen in the mechanism of this reaction. So here one problem is takes place here. This problem is acting like that: benzene tertiary ammonium iodide, that is the benzene tertiary ammonium iodide, which are reacted with the soda amide acting as a base, and what will be the product is given here. It is also acting as the Sommelet Hauser rearrangement reaction. The rearrangement takes place between these compounds and the formation of the methyl derivative NN dimethyl amine takes place, and the product is as like that. Here the product we are writing here. You must be take the mechanism, and if any difficulties occurs, you must be committed on the channel. Here is the attach of CH3 group is takes place, and here CH through N, CH3 and CH3. This is your the product. This is product, and this is the methyl derivative which attached on the ortho substituent for this reaction. Thanks for watching. Like, subscribe and share.